today's topic, we're going to go over reflection of light. First off, I want to open the floor to some discussion. How do we see light? Does anyone have an idea? No? All right. It's reflected from the objects that we are viewing. Can we see in the dark? Feel free to answer this.
Sometimes, kind of.
How about absolute dark? Can you see?
No.
Why?
No light.
There's no light. We only see because of the reflection of light off of objects. There's no projection coming out of our eyes. Same thing with the moon. Does the moon have its own light source?
No.
No, it doesn't. We only see because light reflects off the sun. Sun is a source of light. Light bulb is a source of light. We can see things because the light from those objects reflects off things and goes back into our eye. All right, now to turn to our worksheet, we are going to introduce light in a more quantitative way. So if you want to follow along, two most basic tenets of reflection is the law of reflection. So the first one states that the angle of incidence is equal to the angle of reflection. Now I'm going to label those with you in just a second. The second law is incident ray, reflected ray, and normal all lie in the same plane. Now if we don't know what a plane is, think of a plane as a piece of paper, one dimension. When we have those rays, incident and reflected ray, and a normal, they all lie in that same piece of paper. Now, we have the ray of light falling on the surface. Anyone have any idea what that would be? No. Reflected ray. A reflected ray is a ray coming in. Now, the line that is normal to the surface, where it strikes a mirror, would be your normal line. And it is a line drawn perpendicular to a reflecting surface at the point of incidence. Which brings into the next point, very important point, labeled here P, is our point of incidence. This is where light strikes the surface. Point of incidence. That's P. Now, the incident ray, teacher mistake, should have pointed out, this is incident. This is incoming. Real life mistake. Ray coming out, that's our reflected ray. We're looking at our sheet. That one's right here. Normal is a very important line. You want to make sure that's always drawn perpendicular to the surface. Now, I said perpendicular. Do we know what perpendicular means? If you don't, it means it's 9 degrees to the surface. Last things to label here are labeled I for an incident ray and R for a reflected ray. And it's very important to know that incident and reflected ray are always taken as measurement from the normal line. Fill it in, angle, incidence, and angle of reflection. In case we didn't get all that, there it is filled in there. Now, what we really want to do today is try to go over how to see light as a ray. So I said already that light can be represented as a ray. We can think of light as a particle. It's in motion. Light isn't instantaneous. When we turn on a light bulb, even though we can't see it with our eyes because it happens too fast, it takes time for light to travel. That's why we can represent it as a ray. So, for our worksheet, turn to a blank page, we are going to go over the same labels that we just did in our other diagram. So if you get confused, you can always go to that diagram as a reference. So, this is going to be our flat surface. We're going to call that in here. We have light ray coming in. What would that be called? Coming up to class. Instant ray. Now, this imaginary line that doesn't actually exist, that makes a right angle to our surface. This little square means right angle. What does that one go?
Perpendicular. Right angle.
Perpendicular. This line's called our normal. Very close up. It is perpendicular to the surface. And the one coming away from the mirror, bouncing straight off, that would be Heather.
The reflected ray?
Reflected ray. Matt, can you tell us what would be the angle of incidence? Which side?
Which side?
Yeah. Is it this angle of incidence, or is it this one?
I want to say the second one.
Second one. See, that's the angle between the reflected ray and the normal.
Mm-hmm.
The angle of incidence always refers to the incident ray. So it's actually right here.
Oh, I got it.
And then by extension, the other one's angle of reflection. All right, so we got everything labeled. Now, if angle of incidence is equal to 20 degrees, the angle of reflection will be equal. I think I heard the answer. What will it be?
Equal, so 20.
20. Perfect. We're going to go over some more examples of that later in class, but we're going to move on from this. Looking at your worksheets, we have different types of reflection. We have a regular reflection and we have irregular reflection. Regular reflection we can think of as a mirror. So, light ray comes in, the other one goes out, and have a perfect reflection. It's easy to see that the angle of incidence is equal to the angle of reflection. But how about, for example, this projector right here? Is this showing the law of reflection? It seems like it's not, because you can see this whole piece of paper and you don't see individual light beams. What's actually happening here is it's reflecting off an irregular surface. So we have irregular reflection. So a mirror is a very smooth surface. If you look at a piece of paper under a microscope, it's not a smooth surface, so we actually have light scattering. So just as it is in here, if it will refocus, there we go. Pretending this is our piece of paper. It's a irregular surface, so you have light scattering in a lot of directions. So, even though it doesn't look like, light is reflecting from a single surface, it actually is, because it's an irregular surface. Light scattering in all directions and goes back into your eye to see it. So, for For next class, we will be going over refraction. So please review reflection, please review these notes. If you don't have them with you, they will be posted online.